Okay, so here's your review. So first thing we talk about is inverse functions. So there's two things I want you to be able to do. One is to find the inverse of a function. So given a function, find its inverse. So here's an example. So the first thing you do is you replace f of x with y. Then you switch the variables. So x becomes y, y becomes x. Then you do the algebra to solve for y. And then you say that the inverse function is this new y value. Now, the second thing, I'm not going to ask you to prove it for this. I'm going to give you a separate function, but to show analytically whether two functions are inverses of each other, you do the composite function f of g of x and g of f of x. And for them to be inverse functions, the result has to be x. So let's say f of x is equal to x cubed plus 1, and g of x is equal to the cube root of y minus 1. So doing the composite functions, f of g of x, here f of g of x should plug in g of x into here. And this should be x minus 1, not y minus 1. So g of x is that. So I'm going to plug that into here. So you'll have the cube root of x minus 1. The whole thing cubed plus 1. Well, when you cube the cube root, you just get what's inside. So the cube root of x minus 1 cubed is just x minus 1. You see the ones cancel out, you get x. So that's the first thing. Then you do f of g of f of x. So that's plugging this into there. So what you get is you get the cube root of the quantity x cubed plus 1. So instead of x, I put an x cubed plus 1. And then I subtract 1. So you see the negative 1 and the positive 1 cancel out. So I just end up with the cube root of x cubed, which is x. So because f of g of x and g of f of x equal x, then I can say therefore these are inverse functions. Another thing you could do if you had a graphing calculator is to plot them. And if the functions are, symmetric around that line, then that would be the way you would graphically prove. Okay, the next thing is these not necessarily in the order that'll be on the test or that we covered them. I'm just going to do them kind of in a random order. So the next thing is just multiplying two complex numbers together. So there you just use FOIL. So we're going to do first, which would be negative 2 times 3. Then we'll do outer. So that's negative 2 times positive 4i. So this is f o I. So I is negative 2i times 3. And then you've got L. So I didn't have room for L. So then you've got negative 2i times 4i. Okay, so the first thing you get negative 6. We got to multiply them, almost added them. Then you've got negative 2 times 4i, which is negative 8i. And then you've got negative 2i times 3, which is negative 6i. And the last one, you multiply the real parts of this complex, not the real parts, but the real coefficient in front of them. So you'll get negative 8. Negative 2 times 4 is negative 8, and you get I squared. Okay, we can go ahead and combine the imaginary parts here. Negative 8i, negative 6, that's negative 14i. Then you have negative 8 times I squared, but I squared is negative 1. So this becomes real. So we've got negative 6 plus 8, because the negative times negative, so it's going to be 2. 8 minus 6 is 2, minus 14i. Okay. So that's how you multiply complex numbers. The next thing is, while we're on complex numbers, it's putting in standard form. So, I'm trying to find it. I wrote it out here. Okay. So let's say f of x is, well, it's really not f of x, it's just the complex number. So given the complex number, so I want to put this in standard form. So standard form is you multiply both the numerator and the denominator by the complex conjugate of the denominator. So the complex conjugate is you change the sign of the imaginary part. And since we're trying to just rewrite it, not change the value, we're going to multiply it by 1, which is just a thing over the same thing. And then we use FOIL, and that's why I ended up putting parentheses around these. So in the denominator, put equals, put the denominator, you're going to have negative 3 times negative 3, which is 9, positive 9. The inner and outer cancel out, so you don't even have to show those. You should know that when you have complex conjugates. And then you'll have negative 9, negative 3 times positive 3, I squared. In the numerator, we're going to have first 4 times negative 3. 4 times negative 3 is negative 12. Outer is going to be plus 12i, because you got 4 times positive 3i. And the inner is negative 3i. And then you're going to have positive 3 times I squared. So in the numerator, we got negative 12. Combine the middle two terms. 12 minus 3 is 9. Then you're going to have 3 times negative 1, so it's negative 3, all divided by 9 plus 9. So you get I squared is negative 1. Negative 1 times negative 9 is positive 9. Okay, finally, we can combine the two real parts. So you have negative 15 plus 9i over 18. And then finally, if you can have a common factor that you can simplify it, and you can see each one of these is divisible by 3. So we divide 15 by 3, we divide 9 by 3, we divide 18 by 3, and there we go, this final answer. So don't forget to simplify it afterwards. Okay, about rational functions. So we're going to have a couple of rational function things in here. They're not going to be super difficult. So I'm just trying to find one. So let's say I have f of x equals 5x minus 8 over x plus 2. So the things that you need to do is you need to know what the x-intercepts are. So there you set the numerator equal to 0 and solve for x. So if you solve for x, you'll get 8/5. So that's 8/5 comma 0. That's your x-intercept. X value with the y 0. For the y-intercept, you set x equal, so this is, we set y equal to 0. For the y-intercept, you set x equal to 0. So you can see we're doing f of 0, and that means you're going to have just negative 8 over 2. You just take the constant parts, which you can simplify down to negative 4, and the coordinates are going to be 0, negative 4. So that's my y-intercept. Okay, then you need your vertical asymptotes. That's where you set the denominator equal to 0. So you're going to get x equals -2. And that's an equation, so that's good. It's solving for x, but it's also a vertical line. Horizontal asymptotes. Notice that we have the same highest order term, which is 1. So you take the ratio of the leading coefficients. So you get, it's going to be a horizontal line. It's going to be y equals 5. So that's the horizontal asymptote. So let's plot that. We may need, I may give you, if you need to plot any additional points, I'll ask you to do that. So all you'd have to do is just plug into the equation. But let me draw this graph first to see where I might have asked you to pick a point here. Okay, so we can plot those things on the graph. So we have our x-intercept, and let's make sure we label our graph. So it's 5/8, so that's 1 and 1.6. There's your x-intercept. Here's my y-intercept right down here, -4. We can draw a vertical line at x equals -2. And we have a horizontal asymptote of 5. So that would be right here, both ways. So, most likely you would expect it to go something like this. So it looks like I need a number over here. Since we have a single root in the denominator, it's going to come back this direction. So let's pick x equals -4. So I might say plot x equals, evaluate the function at -4. So all you'd have to do there is say f of -4 is going to be 5 times -4 minus 8 divided by -4 plus 2. So here we get -28 divided by -2, which is going to be -14, which actually is going to be off the graph, so I probably wouldn't give you that one. And it's going to be +14. So it would be way up here. What did I say? That was 14. So in that case, I might have asked you to do -5. So you'd have 5 times -5 minus 8 over -5 plus 2. So we'd get -25 minus 8 would be -33 over -3, which is -11. Yeah, this is way up here. So that actually would be about right here. So you can see it's I think it's got to come down here at some point. Let's try f of -6. Again, I'm going to tell you what this is. I'm just trying to show that it does actually come down. Make sure I'm doing the right equation here. 5x minus 8. Yeah. Okay. So minus 8 over -6 plus 2. So you get -38 over -4, which is going to be -9.5. So you would finally get into the screen here. So that's 3, 4, 5, 6, -9.5. So it would look something like that. It kind of makes sense because it has to be somewhat symmetric around that point. Anyway, that's the bottom line. Take your equation, set the numerator equal to 0, that gives you your x-intercept. Set x equal to 0, that gives you the y-intercept. Set the denominator equal to 0, that gives you your vertical asymptote. Look at the highest order terms, to determine what kind of asymptote you have. Okay, let's look at a one with a slant asymptote. So in that case, the order of the numerator has to be greater than the denominator, so that there is no horizontal asymptote. There's actually a slant asymptote. So I'll give you something like that. And what you do is you use long division to come out with what the result is from this long division, and it'll have a remainder, but the remainder will not be important as far as the slant asymptote. The slant asymptote is going to be the equation that you get up here, and it's an equation. I'll reiterate it in a second. So, okay, long division says, what do I need to multiply x by to get x squared? So the answer is x. So multiply it out. X times x is x squared. X times 2 is 2x. And so I subtract this, make sure I get 0 for both of them. So we'd have x plus 0 is equal. So this is for my remainder. So if I were to write the function, it would be x minus 5 divided by x plus 2. So that's just this equation rewritten or simplified. The slant asymptote is a y equals x equation, and you just take this part, whatever's up here. And then yours is going to have something plus or minus some number, so don't forget that. It just turned out that when I made up this problem, I guessed one that gave me a slant asymptote of y equals x. So don't say just x. You need to show the equation y equals x. Okay, I think I have one more rational function problem somewhere here. Let me see. Maybe that's it. Let me just have 2. Sure seemed like I had 3. Oh, yeah, there's one I don't. So one of them I ask you to plot. The other one I don't ask you to plot. I just ask you to come up with the answers as far as x, y intercepts and vertical asymptotes and horizontal asymptotes. So this is one where the order of the numerator is less than the order of the denominator. This is x to the first power, this is x squared. So the horizontal asymptote of this would be 0. The other one we had the same order, and this one is greater, so we'll have all 3 of them. So again, you use the same procedure that we used in not this immediately past one, but the one before that. So the x-intercepts, we set the denominator equal to 0. Solve for x. So here you get x is going to be 3/2, because you'd add 3 to both sides and divide by 2. Okay, so it's going to be 3/2 comma 0. So this is the point. That's the x-intercept. The y-intercept, you set, here you set y equal to 0. Well, actually, you set the numerator equal to 0, which makes that go to 0. The y-intercept, you set x equal to 0. So you're doing f of 0. So again, you take the constants that are in the original equations. So again, it's a coordinate, it's 0 comma negative 3/5. I'm going to go ahead and plot this one, even though I'm not going to ask you, just to give you another example of how you plot stuff. The next thing you do is you find the vertical asymptotes, and there you set the denominator equal to 0, and you'll be able to factor this. So you take the polynomial in the denominator, and you're going to factor it. So how do you factor it? You say, okay, what 2 numbers multiplied together give you 5? Okay, well, there's only one choice here as far as whole numbers. And it's positive, so either I'm multiplying -1 times -5 or +1 times +5. The middle term is positive, so these are going to be both positive. So that's the factoring. This is an equation. Vertical asymptote is an equation. So the equation is going to be x plus 5 equals, well, it's going to be the equation that makes this happen. This has to be 0 to make that 0, or this has to be 0. So if you solve for x, you'll get x is -5, x is -1. this is specifying an x value, but it's also an equation. So I want you to show it as an equation. And then the horizontal asymptote, in this case, because this is the first power and this is the second power, it's just y equals 0. So given that information, we should be able to plot it. So again, it's just giving you one more example of plotting stuff. So you've got the x-intercept, which is, what was the x-intercept? I already forgot. It's 3/2. So let's put some numbers here. -10, 10, 10, -10. Okay, so the x-intercept's 3/2, which is 1.5. The y-intercept was -3/5, so that's about right here. We have two vertical asymptotes, one at x equals -5, which would be here, and x equals -1. And we have a horizontal asymptote of 0. And I see a problem. The problem is, if I have a, well, no, actually I don't see a problem. So because this is down here, it's going to have to come up like this. And it's going to go through this y-intercept. It'll go through 0, but then it has to come back down again because you have a horizontal asymptote like that. And let's just draw a line here. So my horizontal asymptote is y equals 0. Likewise, it's over there. This is a little more difficult than you would normally expect, but I'm going to just show you. So because we have a single root here, we know that we have to go all the way to positive infinity. And because there's no x-intercept, we know that this thing is going to come down to some point and then has to go back up again. Because if it went down and through, you'd have an x-intercept. If it came down through and came back up, you'd have two x-intercepts. But we don't have that, so that's not going to happen. And then finally, this is going up to positive infinity, so this one has to come from negative infinity. And then it has to approach the horizontal asymptote. So this one, that's one reason I don't ask you to plot this, because it's much more complicated. And I'm just going to show you this is true. Sure hope it's true. So, so what we had was 2x plus 3 divided by x squared plus 6x plus 5. Graph it. And, uh-oh, what happened here? Did I enter that correctly? I might have written something down wrong somewhere. Okay. Ah, yeah, okay. You probably already figured that out. Oh, so I've wrote negative here, so let me put negative in there. On my paper I wrote positive, but it doesn't matter. We can put a negative sign in there. Just that one little sign, you can see it changes a lot. Okay, so there it is. Originally I had a 2x plus 3, but I wrote down 2x minus 3, and that's why that one. So if I were to do this, if I had done this, I probably would have asked you to evaluate the function at this point, which would be -3, and maybe at -7, just so you had those 2 points to help you out. I can do it because I've done a lot of these, but you know, it's not an insight that you're going to get in this class by the number of problems that we do. Okay, continuing on. Let's talk about quadratic equations in standard form. So, and in addition to putting it in standard form, I want you to be able to find the x-intercepts and the y-intercept and the vertex. So all those three things. Besides, once you get it in standard form, you can get it easily. Even before we do it in standard form, though, f of 0, which is going to be -7, because these both will go to 0. That's your y-intercept. So we know the y-intercept is going to be 0, -7. Okay. Now, to get the other two things, the vertex and the x-intercepts, we're going to put this in standard form. So notice I have this coefficient out in front of x, and I'll make it so that you can divide this by that. So I'm going to factor out that constant 4, which means I've got to factor it out here, which means I just take this number, divide by 4. So that's going to be -4x. I'm going to leave a space, and then I'm going to take my constant and put it out there. So you can see it's the same thing. If I multiply this, I'll get 4x squared, and then 4 times -4 is -16. So I haven't changed anything yet. Next, you take the coefficient in front of the x term, you divide by 2, which is always 2, you square it. So -4 divided by 2 is -2, -2 squared is 4. So remember what this is, we'll need that later. So what we're going to do is we're going to add 4, but because I'm adding 4 here and then I'm multiplying by 4 here, I'm really adding 16 to the whole equation. So I'm adding 16, I need to subtract 16. Now I can rewrite the thing inside the parentheses as x. This thing I've got green underlined here, -2, x minus 2 squared, and then I'll have -23. -7 minus 16 is -23. Okay, so now we can do the vertex. Vertex is going to be 2, -23. So this is, remember, this is x minus h. So h is 2, because I've got minus h. Or you can say just take the opposite of -2, which is +2. And then this is your y value. You just take that straight. Okay, now to find the x-intercepts, you set the equation in standard form equal to 0, and then solve for x. So we can add 23 to both sides. That'll end up with that. Divide both sides by 4. Take the square root. Plus or minus. X minus 2. Add 2 to both sides. So you get 2 plus or minus the square root of 23 over 4. The square root of 4 is going to be 2. So you get 2 plus or minus 2 times the square root. No, I got it. It's in the denominator. So it's not that one. It's going to be the square root of 23 over 2. So those are your x-intercepts. So we probably should show them as points. So it's going to be 2 plus the square root of 23 over 2, comma 0, and 2 minus the square root of 23 over 2, comma 0. So we've got everything now. We've got the equation in standard form, got the vertex, we already had the y-intercept right here, y-intercept, and then the x-intercepts. Okay. And you're going to end up with some kind of square root thing, so don't be surprised. Okay, I'm going to give you a third order polynomial. And I'm going to give you 1, 0. So I'm going to say x is equal to -2. And then I'm going to ask you to find the other 0. So what that means is you're going to use synthetic division to divide this by essentially x plus 2. But remember, here you put the 0 here. Okay, so this comes down 1. 1 times negative 2 is negative 2. Add these together, you get negative 6. Negative 2 times negative 6 is plus 12. Add these together, you get negative 7. Negative 2 times negative 7 is positive 14. We get a 0 remainder, so that means that this is a 0. We also know that the factor is x plus 2. The 0 is x minus 2. Now, we take what's left over, 1x squared minus 6x minus 7, and we want that to go to 0 too to factor it. So this will be something you should be able to factor. You won't have to use completing the square or the quadratic formula. You really won't have to use the quadratic formula at all. You shouldn't have to. So what two numbers multiplied together give you 7? 1 and 7. The difference is 6. 7 minus 1 is 6. And I have negative 6 here, so I put the negative on the larger one. So those are the factors. The zeros are x equals 7 and x equals negative 1. So I would say if I asked for the zeros, I'd say they're x equals negative 2, x equals 7, x equals negative 1. And if I wanted to write the original equation in its factored form, I'd do multiply the factors together. So I'd have x plus 2, and then I'd have x minus 7 and x plus 1. So that would be the factored version of the original expression. And if I wanted to plot this, I'm just going to ask you to plot it knowing the end behavior and the zeros. I'm not going to ask you to plot any additional points just because you're not going to have time to do that. So what you'll do is you'll plot the zeros. So you'll have negative 2, negative 1, and 7. 1, 2, 3, 4, 5, 6, 7. And because the leading coefficient here is positive, the end behavior is going to be like this and like that. So you would just draw it up. Because these points are so close together, you probably don't expect it to go very high. And then it's probably going to dip down a lot and go like that. So, and let's just look at it, see what it really does look like. X cubed minus 4x squared minus 19x minus 14. So there it is. If we zoom out in the y direction, you can see it goes way down here, which is not anywhere close to how far we go down. That's why you would need some extra points. It did go up a very small amount here. If I zoomed in again, it went up to about 2. So that was pretty good approximation there, but it really goes down to negative 91. But I'm not going to ask you to plot. I'm just going to ask you to get the end behavior right and through the zeros right. Okay, I want you to do a long division. So even though you could do this using synthetic division, I'm going to ask you to do long division. Now, one thing you got to be careful about, if there's any missing terms. So here you can see there's no x squared and there's no x. So we have to insert those in there and show that by putting zeros. So you have plus 0x squared plus 0x minus 10. And we're dividing by x minus 2. So we just go through the whole procedure. Just have to be careful. What do we need to multiply x by to get x to the 4th? X cubed times x is x to the 4th. X cubed times negative 2 is negative 2x cubed. We're really subtracting it. So this goes to 0. Then we have negative 4 plus 2. So you'll get negative 4 plus 2 is negative 2x cubed. Bring the next one down. Okay, so we're going to add the next term. What do we need to multiply x by to get negative 2x? Which actually need to have a negative sign here. So you get negative 2x squared. Negative 2x squared times x is negative 2x cubed. Negative 2x squared times negative 2 is positive 4x squared. Okay, we're really subtracting those. So that goes to 0, and then I'll have minus 4x squared. Bring down the next one, 0x. What do I need to multiply x by to get negative 4x squared? Negative 4x. So I'll get negative 4x squared. I'm going to multiply here, and I'll get plus 8x here. Again, I'm subtracting it. So negative 4 plus 4 is 0. 0 minus 8 is negative 8x. Bring this down, negative 10. What do I need to multiply x by to get negative 8x? Negative 8. So negative 8 times x is negative 8x. Negative 8 times negative 2 is plus 16. I'm really subtracting that. So I get negative 10 minus 16, which is negative 26. And I'm going to ask you, what is the significance of the remainder? Well, the significance of the remainder is that the value of the function, not at negative 2, but at positive 2. So it's the 0, what is this corresponding 0? So it's saying f of 2 should equal negative 26. So let's just double check that. So if we plug, and that's f of the numerator. So f of 2 is going to be 2 to the 4th minus 4 times 2 cubed minus 10. And that's 16. Here we have 8 times negative 4, which is going to be 8 times negative 32 minus 10. That's 16 minus 42. If you do 42 minus 16, you're going to get 26. So this is negative 26, which is what we got down here. Okay. I'm not going to ask you to, I'm just asking you what the significance of that. And the significance is it's the remainder is the value of the function at the 0 corresponding to this factor. Okay. 2 more problems. So I'm going to give you a 4th order equation. I'm going to give you one complex root, and you're going to have to figure out what the other roots are. Now I'm not going to give you a really super hard complex root because it would take you forever, and there's a lot of room for error. So what I'm going to say is one of the zeros is going to be equal to, in this case, not on the problem, but it's going to be, what am I going to use here? Is going to be 3i. So I'll give you one complex root. So then you can say, oh, well, I know the other one. It's negative 3i. Okay, so whatever this is, you take the negative of it. It's really 0 plus 3i and 0 minus 3i. Okay, so those are the zeros. Now if we rearrange it so we have x minus 3i equals 0, which is equivalent to that, and x plus 3i equals 0. Those are the factors. So what we do is we multiply the factors together. And this is pretty easy because the inner and outer are going to cancel out because it's complex conjugate. And then you'll have negative 9i squared. So negative 3 times positive 3 is negative 9. And I squared is negative 1, so you get x squared plus something. You always get plus something because if you had negative, you could factor it, but you can't factor it because it's positive. Okay, so once you have that, then you can use long division to see what you got left over. Now we can't use synthetic division because we have an x squared term. So we got to do the big long way here. So we have x squared plus 9. Okay. What do I need to multiply x squared by to get x to the fourth? So the answer is x squared. X squared times x squared is x to the fourth. X squared times 9 is plus 9x squared. Notice I've got this, 0. You don't need to put it in there. But so now we're going to subtract this. So here you're going to have negative 2x cubed minus 0x cubed. And then you'll have 6x squared minus 9x. So 6 minus 9 is negative 3x squared. I'm bringing the 18 down. We're going to need that in a second. What do I need to multiply x squared to get negative 2x cubed? Negative 2x is the answer. And so then I multiply it out. So I'll get negative 2x cubed. When I do that, I'll get 0x squared and negative 18x. So I'm really subtracting this. So these go to 0. This one just comes down from here because there's 0 there, and this goes to 0 because I have negative 18 plus 18. And then I bring down the negative 27. Okay. Finally, what do I need to multiply x squared by to get negative 3x squared? So the answer is negative 3. So negative 3 times x squared is negative 3x squared. Negative 3 times 9 is negative 27. Really subtracting it, you get 0. Okay, so what that means is that this original polynomial can be rewritten as x squared plus 9 times x squared minus 2x minus 3. But it's going to be such that you can factor this part. Again, they're going to be whole numbers. What two numbers multiplied together give me 3. 3 and 1. I've got a different 3 minus 1 is 2, so I can do that. So I'm going to put a 3 and a 1. Because this is negative, I'm going to put the negative with the bigger one, put the positive with the smaller one. And there is your answer. So that's what I'm looking for, is the final factored version of the original quadratic. And then the final problem is just listing the possible rational zeros for an expression. So let's say I have 5x cubed minus 7x squared plus 9x plus 12. So the rational zero test says you take plus or minus the factors of the numerator. So you have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So those are the factors of the last term, and then you do plus or minus 1 and plus or minus 5 for the denominator. So you can come up with all of these. This was so I want you to list them all. In this case, it's a lot more. I'm not going to. The one I have for you is maybe I don't know, maybe 10 or 11 or something like that. But I'm just going to show you how to do it. You won't have quite as many to do, but if you start at the most negative, you'll have positive 12 over negative 1. So you'd have negative 12 there, and then you'd have negative 6, and then you'd have negative 4. Now what I'm doing is I'm looking for the next larger one, 12 fifths. So I think then you'd have negative 12 fifths, and then you'd have negative 3, No, it'd be still the other way around. This is still negative 3. And then negative 12 fifths. So 12 fifths is between negative 3 and positive 3. I mean, negative 3 and negative 2. And then the next one you have 6 fifths. So we'd have, that would be the next fraction. So you'd have negative 2, which would be the next one in size. Then you'd have negative 6 fifths, because then 6 fifths is between negative 2 and negative 1. So then you have negative 1. And then you could do all the fractions that are between negative 1 and 0. And then you could have all the positive varieties. Like I said, this one's got a lot more, but it gives you this idea of trying to look at all these different fractions and then put them in the order, numerical order that you would expect. So you can see how these are all ranking, and you can you could mark them off if you wanted to make sure you got them all. You know, this one's that one, then you do that one, and then you do that one, and then you do that one, then you do that one, and then you do that one. So those are all the whole number things, dividing by plus and minus 1. And then you'd have all the fractions, 12 fifths, 6 fifths, 4 fifths, 3 fifths, 2 fifths, 1 fifth. Okay, so that's all I'm asking you to do, is to list all the possible rational zeros. It took me 15 minutes, believe it or not, it took me 15 minutes to do the problem without talking, without all the explanation. So you're going to have an hour and 15 minutes, so you should have time. And again, the key thing here is, I'm showing you examples of ones that are like on the test. And if you think, oh, I'm just going to write down the review and then I'll get an A on the test. But, if you have to sit there and think about, what did I write down? I don't really understand what I'm doing here. The cheat sheet should be something that is only used to help you if you forget something. You just freak out and you can't remember anything. And you then look at the cheat sheet and it should then go, oh yeah, I know what that is. And then you can go on. But you really need to know how to do this stuff without a cheat sheet so that you can do it quickly enough that you're not going to run out of time. So if you do run out of time, it's just you're not prepared enough. I could give you an infinite amount of time and maybe you could figure it out. There's probably a few people that could do that. Usually what happens is people will write down the review and then they'll think, oh yeah, I did the review, I did really good cheat sheets, but they haven't been understanding the homework, they haven't been asking questions in class. They're still not going to do well. So that's my pep talk to doing all the other work that's necessary. At least I'm not asking you to memorize the formulas. But hopefully you've done enough of them that you have a general idea of what you're doing anyway.